Good morning, my YouTube viewers. Crystal here. I wanted to go over a code review with you for the analytics VidHaya competition question. It was a healthcare competition question. Basically, I've been working on it for a long time. I had to do a lot of work on the data sets, and I had to do feature selection, and so I decided upon what I was going to do to the data sets and what features I was going to include in the calculation, and I still didn't get a very high score. The reason why is because I had to predict the probability, and predicting the probability is different from predicting the outcome. And so I did my best to predict the probability, and I made the decision to leave some columns in my feature selection, and I only got like a 50% score, but the highest score on the leaderboard was 78, even though I personally only got a 50% score. So I did my very best to work really hard on this solution, and I decided, well, I'm going to go ahead and do a code review anyway, because it's a good solution, even though the score was the probability. It wasn't the outcome, it was the probability. So I'm going to go ahead and read you the problem statement. Congratulations, you've been hired as a chief data scientist at MedCamp, a not-for-profit organization dedicated in making health conditions for working professionals better. MedCamp was started because the founders saw their family suffer due to bad work-life balance and neglected health. MedCamp organizes health camps in several cities with low work-life balance. They reach out to working people and ask them to register for these health camps. For those who attend, MedCamp provides them facility to undergo health checks or increase awareness by visiting various stalls depending on the format of the camp. MedCamp has conducted 65 such events over a period of 4 years, and they see a high drop-off between registration and number of people taking tests at the camps. In the last 4 years, they have stored data of approximately 110,000 registrations they have done. One of the huge costs in arranging these camps is the amount of inventory you need to carry. If you carry more than required inventory, you incur unnecessarily high risk. On the other hand, if you carry less than required inventory for conducting these medical tests, people end up having had a bad experience. And it said in the analytics VidHaya problem statement, which I didn't include, it said MedCamp employees, volunteers reach out to people and drive registrations. During the camp, people who show up either undergo the medical test or visit stalls, depending on the format of health camp. And then it talks about a favorable outcome. For the first two formats, a favorable outcome is defined as getting a health score, while in the third format, it is defined as visiting at least a stall. You need to predict the chances probability of having a favorable outcome. So the first thing what we'll do is we'll talk about the process that I used to solve this problem. Even though I didn't get a very high score, I still feel that I did a good job nevertheless. And the reason why is because I didn't have to predict the outcome. I had to predict the probability. So, that's why I didn't score very high. So the first thing we did was we loaded our libraries, and I'm loading my libraries differently now, because now that I'm doing blog posts, I'm actually putting the libraries that I load in with the procedure that I want to perform, so I can put that in the blog post. So that's why I only imported NumPy and Pandas in the beginning. And if you go onto the Kaggle website, that's all they do in the beginning either. They just import NumPy and Pandas. And then I imported the data sets. You can see there were a lot of data sets. There was train, test, sample, first, second, third, camp, and patient. So here's your train data set. Train is patient ID, health camp ID, registration, VAR1, VAR2, VAR3, VAR4, VAR5. And then I tested for missing values, found out that there were missing values in the registration date, so I replaced any missing values with mode. The next thing I did was I tested the test set, which was exactly the same format as the train data set. We didn't have any missing values, so we checked the sample sub. So this is the submission that Analytics VidHire wants to see. We checked the first. That was the first camp. So we checked patient ID, health ID, donation, health score, and an unnamed column. So I dropped the unnamed column, and then originally I had dropped the donation because the donation only occurred in one instance, but I decided to go ahead and keep the donation in really after I started making this video the first time, just to see if it would improve my score. And it's a hard call. It's a difficult call to make, but I went ahead and kept the donation in, and I used it in my calculation. I got a higher score when the donation was used and a lower score when the donation was dropped. So it was a difficult call to make as to whether to leave the donation in the feature selection or not. And so I decided to leave it in the feature selection. The next thing we did was we checked the second. The second had patient ID, health camp ID, and health score. We checked the third camp. You had patient ID, health camp ID, number of stalls visited, last stall visited number. So we had a file on the camp itself. You had health camp ID, camp start date, camp end date, category 1, category 2, category 3. And then the next file we had was patient. We had patient ID, online follower, LinkedIn shared, Twitter shared, Facebook shared, income, education score, age, interaction, city type, employer category. We checked to see if we had any null characters, and city type and employer category were null characters. So we replaced those with mode. So now what we've done is we've created our train and our test data sets. So basically now what we did was we merged a lot of files together. So we merged the first, we merged to the train, we merged the first, second, third, patient, camp. And so we merged all of these to the train data set, and then we did exactly the same thing with the test data set. So we'll just go over that again. First, second, third, patient, camp. So that was everything that was merged together. So we created our data train, and you can see the data train we created. And we created our data test. You can see the data test that we created. So we checked for any null values on our train file, data train file, and we checked for any null values on our data test file. And so what we did was we replaced any null values with 0. And we did that on the data train file and the data test file. So now in our data train and data test file, any null values have become 0. And now what we had to do was, this is the first time that I've used this, but I've read about it. We used a binarizer, and what we did was we created an extra column called outcome. And this extra column takes the score, health score, number of stall visited, and last stall visited. And it will give you a 1 if those values are above 1. So basically, and then we created a column to do that. So that's going to be your target variable, your outcome. And you can see here, so your health score, we had some health scores. One was 0.927746. We had some number of stalls visited, and we had last stall visited, because a favorable outcome was if they got a health score or they visited stalls. So we had to use all of those. And then we used this binarizer. And so if the value was above 0, then it gave you a 1. And if the value was 0 or below, then it gave you a 0. So that was your outcome. And it told you whether it was a positive outcome or not, because a positive outcome was if they got a health score or they visited a stall. We did the same thing with the data test, except the data test doesn't have an outcome column, because the outcome column is your target. It's your dependent variable. Now what we did was we processed the data. So the first thing we had to do was we had to convert the floats. We had to convert the date to integers, because that's what I wanted, because that's what the computer wants to see. The computer wants to see integers. So we converted the date to an integer, and this is the code to convert the date to the integer. And then we replaced the zeros with median. And then what we did was we label encoded all of the objects that were strings. We label encoded those to give those a numeric values. And then we converted columns to integer, because I wanted everything to be an integer that could be an integer. And so here's your data train file. Your data train file is all cleaned up. It's got lots of zeros in it, lots of integers in it, and then you've got an outcome. Now we've done a graphical representation, because people like to see graphics. So this is your outcome. Only approximately 8% of the people who attended the workshops, it was a positive outcome. The rest of them, I would say 92% of the people who had registered, it didn't get a positive outcome. And that was the problem, because this not-for-profit organization, they were bringing lots of stock with them, and people were registering for the event, but they weren't turning up, and they were bringing all this extra stock. And that's what they wanted to do. They wanted to predict the probability of a favorable outcome. So they didn't necessarily want to predict a favorable outcome. They wanted to predict the probability. So now what we do is we define R, X, Y, and X test. So patient ID equals test data patient ID, and health camp ID equals test health camp ID. So that's I don't think it's going to make that much of a difference, because you've got test and you've got data test, and it worked, but it doesn't, obviously it's not what I wanted, because I didn't delete the test file or anything like that, but I'll go ahead and correct anyway. So now we've defined our X, Y, and X test. Y is your data train outcome. So that is your target variable. It's your dependent variable. And X is your data train, but they drop certain files. They drop patient ID, health camp ID, outcome, health score, number of stalls visited, last stall visited. And the X test was the data test, and they dropped everything except the outcome because it didn't have an outcome. So I decided to use SMOTE, and SMOTE is it's like synthetic sampling when you have a categorical imbalance. And since only 8 of the people who registered had a favorable response, I decided to use SMOTE to do synthetic sampling to put the sampling rate on a more even keel. And now what I've done is I've split my test setup in for training and testing. We selected our model. I selected HistGradientBoostClassifier. That seemed to work, and it seemed to give me an outcome. The loss was binary cross entropy, because we were working with binary data as 1 or a 0. And I experimented on this a lot, and so I came up with max leaf nodes is 50, learning rate is 0.01, max iterations is 3,000, and random state is 1. And then we fit the model. So what we did was we printed our score, and you see we had a score of 1. So our score was a good score. I mean, it was a good outcome. We checked the ypred equals model.predict xval. And so you see you have an outcome of 0 or 1. Again, we had a good score of 100%. So it was a good algorithm. There was nothing wrong with the algorithm. And now what we did was we created a data frame to show the actual outcome opposed to the predicted outcome. And you can see the actual outcome and the predicted outcome were the same, giving you 100%. Now this is where it gets tricky, because we had to use predict proba, because we had to predict on the probability. And that's where it gets tricky, the probability. So we created a confusion matrix, and it just shows you what you had with 0 and 1 on your confusion matrix. And then we created a classification report. Again, we had 100%. And then so we made our predictions. We predicted on the X test, so you had lots of zeros. But again, we had to check the probability. And so when we checked the probability, that's where it got a bit tricky. So this is a sample of what Analytics VidHaya wants to see. They want to see patient ID, health camp ID, outcome. And then we outputted our print proba to a file of patient ID, health camp ID, and print pred proba. And then we submitted our submission, and you can see we had patient ID, health camp ID, and outcome. So the probability was quite low of a positive outcome. And then what you would do is, when you finished all that, you would go to your sample submission and you would download it. And then when you downloaded it, you were able to upload this sample submission into Analytics Vidhya website. And when I uploaded it to the Analytics Vidhya website, for what I decided to do on this particular instance, I got a score of 50 when the highest score was, I think, 78. So it was very difficult because you're not really predicting on the outcome, you're predicting on the probability of an outcome. And I still think it's a good algorithm, even though I didn't score that high. I had scored higher. If I had left some information in there, I would have scored higher. But if left I'll show you, if I'd left in some of the columns, like the health score, the number of stalls visited, and the last stall visited, then I would have got a higher score. But I thought about it, and I thought, well, the outcome was dependent upon the health score, the number of stalls visited, and the last stall visited. So that wasn't really relevant because the outcome was actually a combination of those three. And then I thought about whether or not I should delete the donation because we only had one donation in one of the camps, and the rest of the camps that didn't talk about donations. But I made the decision to leave the donation in there as well. So this is it. I did my best, and that's why I wanted to show it to you. This is on Google. Unfortunately, the way they do it with Analytics Vidhya is it's not stored on the website. You can store the website. You can actually go onto the website, and then when you upload your code, then your submission, you have an opportunity to upload the upload the program as well. But I don't know if I'm going to do that or not. I can upload the program, and you can look on it on Analytics Vidhya if you want to. I mean, my handle is Tracy7, so I might go ahead and do that for you, even though it wasn't a very high score. So that concludes it for this video presentation. Another place I'm going to put it is I'm going to put it on GitHub. That's what I'm going to do. I'm going to put it on GitHub so you can see it on GitHub. And my handle on GitHub is Tracy Renee 1961, but you can find it